Chapter 1. Computer Networking. Computer Network. Computer network is a backbone of modern communication. A computer network is a collection of interconnected devices or nodes. It enables the users to exchange information or services with seamless connectivity among devices, computers, and systems. These networks play a crucial role in facilitating efficient data transmission, collaboration, and access to a vast array of digital resources. Advantages of computer network. As you know that computer network facilitates the sharing of resources among connected devices. Now, learn the various advantages of computer network. It allows seamless communication via email, video conferencing, messaging, and other applications. It also enhances collaboration and information sharing within organizations and globally. It allows to share the resources, leading to cost savings. It allows the users to connect to the network from anywhere, providing the freedom to work or accessing information while on the move. It allows for centralized data management, making it easier to implement security measures to protect sensitive information. Terms related to computer network. LAN, local area network, a network confined to a limited geographic area, typically within a building or campus. 1. Wide area network, a network that covers a broad geographic area, often connecting multiple LANs. IP address, Internet Protocol address, a unique numerical identifier assigned to each device on a network, allowing communication between devices. Protocol, a set of rules that govern data communication on a network, ensuring seamless and standardized communication. Bandwidth, the maximum data transfer rate of a network or internet connection, typically measured in bits per second, BPS. Router, a device that discovers routes and ensures data reaches its intended destination. DNS, Domain Name System, a system that translates human-readable domain names into IP addresses for computer use. Packet, a unit of data sent across a network, containing both the actual data and control information. Topology, the physical or logical arrangement of devices in a network, defining how they're connected. Terms related to computer network. LAN, local area network, a network confined to a limited geographic area, typically within a building or campus. 1. Wide area network, a network that covers a broad geographic area, often connecting multiple LANs. IP address, Internet Protocol address, a unique numerical identifier assigned to each device on a network, allowing communication between devices. Protocol, a set of rules that govern data communication on a network, ensuring seamless and standardized communication. Bandwidth, the maximum data transfer rate of a network or internet connection, typically measured in bits per second, BPS. Router, a device that discovers routes and ensures data reaches its intended destination. DNS, Domain Name System, a system that translates human-readable domain names into IP addresses for computer use. Packet, a unit of data sent across a network, containing both the actual data and control information. Topology, The physical or logical arrangement of devices in a network, defining how they're connected. Basic requirements for a computer network. These are some basic requirements that are essential to setting up a reliable computer network to establish efficient communication and resource sharing amongst connected devices. Devices. These two devices are mandatory for a computer network. Computers and servers, core devices that utilize the network to share and access data. Switches and routers, devices that manage and direct data traffic within the network. A well-planned network design, and these are the hardware components, enabling devices to connect to the network, either wired or wirelessly. Cables and connectors, these are the physical components linking devices within the network, such as Ethernet cables and USB connectors. Network communication protocols, these are the standardized rules governing data transmission and communication across the network. Network services, these are the essential services like file sharing, printing, email, and web browsing provided to network users. Networking software, operating systems, and applications enabling devices to connect and communicate effectively within the network. Network security measures, firewalls, encryption, access controls, and other security mechanisms to protect data in a network. Administration and management tools, software and tools for monitoring, managing, and troubleshooting network performance and issues. Networking standards and protocols, these are the established rules and protocols, such as TCP/IP, defining how devices communicate and operate in a network. Power supply and backup, reliable power sources and backup systems to ensure uninterrupted network operations even during power outages. Network design and topology. A well-planned network design and topology to efficiently connect devices and manage traffic flow. Internet connectivity, connection to the Internet, often facilitated through Internet service providers, ISPs, for external communication and access to online resources. Types of computer network. There are several types of computer networks. Each network is designed to serve specific purposes based on their size, coverage, and functionalities. Let's understand these computer networks. Local Area Network, LAN. A local area network, LAN, is a network limited to a specific geographic area, like a home or office. It typically employs Ethernet technology to connect computers, printers, servers, and other devices. LANs offer high data transfer rates and are commonly used for sharing resources, such as files and printers, within a limited area. Wide Area Network, WAN. A wide area network, WAN, spans a large geographic area, often across cities or countries. WANs connect multiple LANs and employ technologies like leased lines, satellites, and microwave links. While WANs have lower data transfer rates compared to LANs, they facilitate communication over vast distances, enabling organizations with dispersed locations to stay connected. Metropolitan Area Network, MAN. A metropolitan area network, MAN, covers a city or a town, providing high-speed connectivity within that specific geographic region. MANs are often used by universities, businesses, or government entities to interconnect multiple LANs and enable efficient data transmission within a metropolitan area. Personal Area Network (PAN). A personal area network (PAN) CAN is also known as Cluster Area Network, connects workspace or immediate environment, connecting personal devices like smartphones, laptops, tablets, and wearable technology. Technologies like Bluetooth and infrared are commonly used to create PANs, enabling seamless communication and data sharing among personal devices. Campus Area Network (CAN). CAN is also known as Cluster Area Network, connects two or more LAN that are limited to specific geographical areas, for example, college campus, office building, etc. A campus area network is larger than LAN since it may span multiple buildings within a limited area. Topology. Network topology is the layout or arrangement of different interconnected elements in a computer network. It defines how devices and nodes in a network are structured and how they communicate. The choice of network topology is an important aspect of network design as it impacts the overall efficiency, reliability, and ease of management of the network. Common types of network topology. Network topology plays a crucial role in determining the overall performance and effectiveness of a computer network. Now learn the different types of network topologies. Bus topology. A bus topology involves a single central cable to which all devices are connected. Data is transmitted along the cable, and each device receives the data, but only the intended recipient processes it. This topology is simple but can face issues if the main cable is damaged. Star topology. In a star topology, all devices are connected to a central hub or switch. The central hub acts as a mediator, managing and controlling communication between devices. This topology is easy to set up and troubleshoot but is dependent on the central hub. Ring topology. In a ring topology, devices are connected in a circular manner, where each device is connected to two others, forming a ring. Data flows in one direction, and each device passes the data along until it reaches the intended recipient. This topology is reliable and has uniform data flow but can be disrupted if one device fails. Mesh topology. Mesh topology is characterized by every device connecting to every other device in the network. It provides multiple paths for data transmission, ensuring high reliability and fault tolerance. However, it requires a significant number of connections and can be complex to manage. Hybrid topology. Hybrid topology is a combination of two or more basic topologies. For example, a network might be a combination of star and bus topology. This provides the benefits of multiple topologies and can be customized to suit specific requirements. Network architecture. Client-server architecture. In this network, clients, devices like computers, request services or resources from centralized servers. Servers respond to these requests and provide the necessary data or services. It's efficient and allows centralized management. Peer-to-peer architecture. In this network, each device, peer, can act as both a client and a server, sharing resources directly without relying on a centralized server. This architecture is more decentralized. Hybrid architecture. Hybrid architecture combines elements of both client-server and peer-to-peer models. It offers the benefits of centralization and decentralization, providing a balance based on specific network requirements. Cloud computing architecture. Cloud computing architecture utilizes a network of remote servers hosted on the Internet to store, manage, and process data. It offers scalability, flexibility, and cost efficiency, making it popular for modern applications and services. Advantages of a well-designed network architecture. Efficiency. An efficient architecture ensures optimal data flow, reducing latency and improving network performance. Scalability. A well-designed architecture allows for easy expansion and adaptation to accommodate growth in users, devices, or data traffic. Reliability and redundancy. Properly structured networks provide backup and redundancy, ensuring continuous operations even in case of failures. Security. A well-designed architecture incorporates security measures to protect data and resources, minimizing potential threats and vulnerabilities. Wireless networking. Wireless networking is a technology that allows devices to connect and communicate without the need for physical cables or wired connection. It has revolutionized the way we access information, communicate, and collaborate in today's digital age. This form of networking relies on radio frequency signals to transmit data between devices, providing mobility and flexibility in connectivity. Components of wireless network. Wireless access points, WAPs. These are devices that create a wireless local area network, WLAN, by connecting to a wired network. They allow wireless devices to connect to the network and access resources. Wireless network interface cards, NICs. NICs are hardware components in devices, example laptops, smartphones, that allow them to connect to a wireless network. For a device to be a part of network, it must have an NIC. Routers. Routers play a vital role in directing data traffic within the wireless network and between the wireless network and the Internet. Antennas. Antennas help transmit and receive radio signals, facilitating wireless communication between devices. Wireless channels. Wireless channels are specific frequencies designated for wireless communication. Devices use these channels to transmit and receive data. Types of wireless networking. Wi-Fi. Wi-Fi is the most common wireless networking technology. It operates on radio frequency bands. It is widely used for connecting devices within homes, offices, and public places. Bluetooth. Bluetooth is a short-range wireless technology commonly used for connecting peripherals like keyboards, mouse, headsets, and mobile devices to computers. Cellular networks. Cellular networks are a form of wireless networking that connect mobile devices to a telecommunications network through cellular towers. They enable voice calls, text messaging, and Internet access. Advantages of wireless networking. Mobility and flexibility. Users can connect to the network from anywhere within the coverage area, providing freedom of movement. Easy installation and scalability. Wireless networks can be set up quickly, and it's easy to expand or modify them as needed. Reduced cable clutter. Wireless networks eliminate the need for physical cables, reducing clutter and allowing for a cleaner workspace. Cost efficiency. In many cases, wireless networking can be more cost-effective than installing and maintaining wired infrastructure. Access control. Utilizing strong passwords and access controls, it ensures only authorized users can connect to the network. Regular updates and patches. Keeping devices and software up to date with the latest security measures is crucial for network security. Protocols. Protocols are the foundation of modern communication. These are the set of predefined rules and conventions that govern how data is transmitted, received, and interpreted across a network. They ensure that devices and systems can communicate effectively and accurately with each other. Understanding and implementing protocols are essential for a well-functioning and secure digital infrastructure. Characteristics of protocols. Error detection and correction. Flow control. Reliability. Security. Types of protocols. You know about the protocols and their characteristics. Now learn about the various types of protocols. Communication protocols. These protocols define the rules for data transmission between devices. Examples include TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Internet protocols. Internet protocols are a subset of communication protocols that facilitate communication over the Internet. The most well-known is the TCP/IP, Transmission Control Protocol Internet Protocol, which is foundational for Internet communication. Application layer protocols. These protocols define communication standards specific to applications. For instance, HTTP, Hypertext Transfer Protocol, is used for web browsing, SMTP, Simple Mail Transfer Protocol, for email, and FTP, File Transfer Protocol, for file sharing. Transport layer protocols. Transport layer protocols govern end-to-end communication between devices. Besides TCP and UDP, this includes SCTP, Stream Control Transmission Protocol. Network layer protocols. Network layer protocols focus on routing and forwarding data packets across networks. IP Internet Protocol is a fundamental network layer protocol. Link layer protocols. Link layer protocols define rules for communication within a local network, such as Ethernet and Wi-Fi. In summary, a computer network is a collection of interconnected devices or nodes. A local area network, LAN, is a network limited to a specific geographic area. A wide area network, WAN, spans a large geographic area, often across cities or countries. A metropolitan area network, MAN, covers a city or a town, providing high-speed connectivity within that specific geographic region. A personal area network, PAN, is a small network within an individual's workspace or immediate environment. Cluster area network connects two or more LANs that are limited to specific geographical areas. Network topology is the layout or arrangement of different interconnected elements in a computer network. Wireless networking is a technology that allows devices to connect and communicate without the need for physical cables or wired connections. Protocols are the foundation of modern communication.